So today we'll be going over ECE 388 power supply project, which requires an adjustable voltage and current. So if we move on to the other side of this board, we can see a slightly oversimplified version of the circuit, which can be found in the lab report. We have a DC input with a voltage control, a potentiometer to regulate the voltage, and a current control with a second potentiometer to regulate the current. So where the microcontroller comes into play is we have the ADC, which is necessary for us to measure the voltage and current for it to be displayed later on in the 16:2 LCD. So how do we measure the voltage and how do we measure the current? So the maximum that this circuit can output is 10 volts, and the lowest should be 0 volts. So because the ADC on the microcontroller cannot handle anything above 5 volts, and our maximum is 10 volts, so it would not be able to handle that. So what we did is voltage divider, 10k ohm and 10k ohm, with the voltage division, maximum 10 volts, we would have V sense equal to 5 volts, which the microcontroller can handle. So with that being said, how the current is handled, according to the data sheet, if we know the value of this potentiometer, we can do 1.2 divided by that value, and that would give us the I limit, the current limit. So that's where the ADC comes into play again with measuring the current potentiometer value. So the microcontroller takes all that information and just displays it, does a bunch of calculation, which can be seen in the lab report, and it displays it on the 16:2 LCD. So for us to measure these values and for us to test against them, that were displayed, the values that were displayed, we have the measured value versus displayed here in a table of voltage and current. So we're gonna have test the voltage that is displayed and measure the voltage and check against the one that's displayed. Same thing with the current. Look at the one that's displayed and measure the actual current and see how far off we are. So due to time constraints, the PCB was not able to get manufactured, but we do have a pretty well developed prototype here, which has the LCD, the microcontroller, two LM317s, which are the voltage regulator, the current regulator, and these are the potentiometers. The blue one is for the voltage, the white one is for the current. And this is our voltage divider, and as you can see, the yellow wire is our ADC sense for the voltage that is outputted, and it is right between these two 10k resistors. And this third potentiometer acts as the contrast for this LCD, and the LCD is set up as a 4-bit input. So if you would like more information on that, I go into more detail on the lab report, so you can read more in there. And what I have on the right of me is a multimeter, which I'll be using to test all my values that I'm displaying against. So we can start off by playing with some of the potentiometers. Like I said, this one is the contrast one, and you'll be able to see that. So I can change the contrast of the LCD, so we want it at a good spot where we will be able to see. So right now, I believe both potentiometers are at their maximum value. So the voltage and the this are at their maximum value, and we can change them. So if I bring this down, I get a slowly decreasing voltage. which we can go all the way to 0.5. And I can bring it back up to 6.1. And if we look at the current one, which also can be, if I can get it in, there we go, which also can be changed. As you can see, we can go up and down based on the value of the potentiometer. The only difference is that the current is measured in milliamps versus voltage, which is measured in volts. So if we have both values back at their maximum values so that we can test, this is at their max and this is at the lowest, and this is at the max. So it says the voltage is at 6.1 volts. So let's go ahead and write that down in so 6.1. And what was our current? Our current is 93 milliamps. So let's go with 94. So this is volts, 94 milliamps. And let's go ahead and look our multimeter. It is at 6.3. How is it set up? So we have this at DC volts. We have these two wires connected directly to the output and to the ground. So 6.318. So let's go ahead and write that down. 6.138 volts. So, and for us to test the current value right now, we have to switch this from volts to milliamps. So let's take that out. Switch this to milliamps. But if you notice, this measures both AC and DC, so we gotta make sure we switch to the yellow part, the DC part. So we gotta click on this. As you can see, it's switched to DC, from AC to DC. And then we make sure our value is 94 milliamps. And if we look at that, we go ahead and plug it in. Our value is 96.9 milliamps. So let's go ahead and write that down. 96 milliamps. And with that being said, we can take a look at both. There are pretty close values. It is pretty unnoticeable margin of error, but it's still a margin of error, and I talk about that more and why that could possibly be a reason. I talk more about that in the lab report. And yeah, thank you so much for listening, and signing off.